Hello, thank you for watching this video. So in this video, I'll be doing question 1 of November 2019 question paper mathematics paper 1. And the topic now is equations. So I'll be solving these equations here on 1.1 and 1.2. So I'll start with the 1.1 ones. So 1.1 read as follows. They're saying solve for x, as you can see there, and then they've given you the series of equations here. So they want you to solve for x. So that's what we're going to do now. So we're going to start with the first equation, which is this equation here, which is 1.1.1. It's given as x squared plus 5x minus 6 is equal to 0. So they want you to solve this equation. So two options. You can use the quadratic formula or you can factorize this thing. So factorizing this one is easy. So we'll factorize. So factors of x squared is x and x, right? So the factors of 6, so it should be 6 and 1. So you can have plus 6 and minus 1. So your x plus 6 is equal to 0, or your x minus 1 is equal to 0, right? Therefore your x is equal to minus 6, or your x equal to 1. So this is the first solution to your first equation, which is 1.1. So if you don't know how to factorize, your quadratic formula comes in, right? So on the next one, 1.1.2, they wanted to solve this equation here, and they also gave you an order there and say correct to 2 decimal places. So some sort of a hint that this might not have very easy factors, right? So they might be irrational. So let's use the quadratic formula there, which you can also use on the first one if you're uncomfortable with it. So we're going to use the quadratic formula to solve 1.1.2. So we're going to 1.1.2. 1.1.2 is given as 4x squared plus 3x minus 5 is equal to 0, right? So you know equation is quadratic formula is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? No problem. You know your a is the coefficient of x squared, so it's 4. And your b is what? Who is your b? Your b is 3. And your c, what is your c? Your c is minus 5 over here. So substitute these on your quadratic formula. So you said x is equal to negative b. What is your b? Your b is 3 plus or minus the square root of what? Of b, which is 3 all squared, minus 4a. What is your a? Your a is 4. And your c is minus 5. All over 2 times a, your a is 4. Then you punch this in on your quadratic formula and see what you get. So, punch it, you'll get that negative 3 plus the square root of 3 all squared minus 4 into a, which is 4, to minus 5, into c, which is 4. So, your x is equal to minus 3 plus or minus the square root of what? The square root of 89 all over 8, which is your x is equal to, or your x is equal to. So they said correct to 2 decimal places, so we're going to do that. So when you do, we're going to get 0.80, right? And the second solution is, when you put a minus, get this minus 1.55. So these are your solutions to the second equation, right? Now, going to move to the third equation, which is an inequality. So we did this one, we did this one. Now we're going for an inequality. So they want you at 1.1.3 to solve this equation, 1.1.3. They want you to solve this equation, which is 4x squared minus 1 is equal to 0. So when it's here, already it's good, because it's more like it's in the standard form. So once it's here, you find your critical values. Critical values equate this to 0. 4x squared minus 1 is equal to 0. Then you can use the quadratic formula as you did here to find the critical values, or you can factorize. So I'll factorize this. equal to 0, I'll have 2x here, I'll have 2x here, I'll have 1, I'll have 1, minus and a plus 1, because that's a difference of 2 squares there, right? So your 2x minus 1 is equal to 0, or your 2x plus 1 is equal to 0, because if you're multiplying two things and the product is 0, at least one of them is 0. So it's either this one is 0 or that one is 0. So you get that your x is equal to 1 over 2, or your x is equal to negative half. These are your critical values, right? But we haven't told them for which values of x is this thing less than 0. So the next thing that you need to do to draw this thing, so which is the quadratic function. There's something similar to this. So this is y is equal to 0. This is x equal to 0. So one of the factors is minus half here. And then one of the factors is a positive half. So here we go. We've drawn it. Here is it. So they're asking for the values of x where the function is less than 0, which is where the function is below 0, right? Which is below the x-axis. Where is your function below the x-axis? Your function is below the x-axis where? Here. You can see here. It's below the x-axis. Between this point and this point is below the x-axis. At this point, it is exactly at the x-axis, and at this point is exactly at the x-axis. But they're asking, where is it below? It's below here, right? So what are the corresponding x values? What x values correspond to these things? The corresponding x values are these values that are directly above directly above the portion where your function is less than 0. So it's the x values that are between these 2 points. So your x values must be between minus half and the positive half, because at minus half is 0. That's what we said there. If minus half, oh, okay. This was supposed to, oh, yeah, this is a minus half. So at minus half, the function is 0 and the positive half is 0. But between the two is below 0. So your x values must be between minus half and a positive half. Or you can just say your x should be greater than a negative half, but less than a positive half. So I think it is more or less the same thing, right? And we're done with this one. So at this point, we're left with 1, which is this one here. So let's try and see if we'll find any spaces, right? So what do? It's okay. This is 1.1.4. We're given that this bracket, square root of 32 plus x, right? Close. Square root of 32 minus x, right? Fine. Oh, I haven't written the entire thing. So let me wipe it and then I'll try to write it. I think I'm worried about space constraints. Okay. So in this case, we're given that thing there to be the square root 32 plus x, another square root 32 minus x is equal to x. Right? So they want us to solve for x here. So here you have two brackets multiplying each other. And you need to remember, when you're doing sets, if you say the square root of a times the square root of b, this will be called what? Square root of a times b. So we're going to use this set law here. This square root of this times the square root of that, you will just multiply things that are under the square root. So in this case, you have something like this. Square root, oh, let me make it a bracket. So I'll put this in a bracket. Say square root of 32 plus x times square root of 32 minus x. Right? So multiply these out. This is equal to x, of course. So you multiply these out because you can see they should multiply each other. So let's go. Carry your square root of 32 times square root of 32 Okay, that is 32. Square root of 32 times minus x minus, this will be minus 32 root 32x. X times square root of 32 is plus root 32x minus x squared. Right? This is all under root is equal to x. All of this is under root because it's a product of this. Fine. Now try group the like terms, this and this go away. So under the square root, we're left with 32 minus x squared is equal to x. You're familiar with this because most of the time when they give you this, it's always in this form, right? What you do here, just square both sides like you normally do. And the roots go away, you're left with 32 minus x squared is equal to x squared. Then let's transpose this thing to the other side. What do you get? Get that 0 is equal to, it doesn't matter, you can take this to this side. 2x squared, because it will be, this x will be positive and you add with this one, minus 32. Right? And then from here you can use the quadratic formula or you can factorize. I'll try to factorize. So it says 0 is equal to 2 into x minus 4 into x minus 4 or plus 4. Therefore, your x is equal to 4 or your x is equal to minus 4. So these are x values. You can use quadratic formula here. You'll get these two, right? So now you must check them and see if they are correct. You can see here your x is 4, right? And this side will always be positive, right? This side will always be positive. So substitute your 4 here and there. The answer that you get, this side will be positive, and so will be 4 on the other side, right? But look at this one. This x value is negative. This left-hand side will always be positive, but your right-hand side will be negative if x is equal to minus 4. So this solution is dodgy. So if you substitute your 4 here, you will get 4 there. If you put 4 here and 4 there and punch it as is on your calculator, you'll get a 4. But if you substitute the minus 4 here and minus 4, the answer that you'll get will not be equal to the other side. So the equation will not be well balanced. That's why we're not selecting that one. That's why we're deselecting it. So I think I'm done with 1.1.1 and we're going to go to 1.2, which is solving in 2 equations simultaneously. So let's go and do that. I'm going to clean the board and then we do 1.2. Okay, so now that we're done with 1.1, we're going to move to 1.2, which is written here. So 1.2 read as follows. They're saying solve simultaneously for x and y from these 2 equations, right? So you're given 2 equations, this equation here and this equation here. So they're saying solve simultaneously for x and y. Fine. What do we do? First look at both of them and look which one is the simplest, which one look easier. Of course, the linear equations tend to look easier most of the time. This one is looks simpler, right? Fine. From the simpler one, solve for x or y. So we should make x or y the substitute of the formula. You want to be left with x or y on the side, one of them. So in my case, I want to be left with y here on the left-hand side. So y is equal to, I'll take the x to the other side. So I'll have 12 minus x. Right? So I've transposed the x and I'm left with y, the substitute of the formula. Once I'm done doing this, I'm going to go to the second equation, which is this one here. On the second equation, where you see your y, you substitute it with 12 minus x. So in the place of y, you're going to put this 12 minus x. So what we have there, we have x times y, but our y is 12 minus x now, is equal to 14 minus 3x. What do we do? Simplify this equation. So we will have x times 12, we have 12x, x times negative x minus x squared is equal to 14 minus 3x. So let's take these things to the other side. So we're left with 0 here. You can take this to this side, it doesn't matter, whichever way you want. So I'll be left with x, or I'll have x squared this side. minus 3x, right, which is this one, minus this 12x here, right, plus 14. So 0 is equal to x squared minus 15x plus 14. So once you are here, you can use your quadratic equation, or you can factorize. I'll try to factorize this thing. So I'll try to factor it. I have x here, I have x here. I have 14, I have 1, I have minus and a minus. Therefore, my x is equal to 14. Or my x is equal to 1. As you can see there. Now that we have the x values, we need the y values. So to get the y values, take these x values of yours and substitute them on the equation that gives you, which is the equation that you created, or the first one, doesn't matter. So let's take this one. So in this case, we have y is equal to what? 12 minus x. What is your x? X is 14. So your answer to this will be minus 2. And on the other side, to be y is equal to 12 minus x, which is 1, which is equal to 11. So these are x values and these are your y values. And 1.2 ends like that. So you are done with this simultaneous equation. So we're going to move to what? To 1.3. Okay, so now we're doing 1.3. 1.3 reads as follows. They are saying consider the product. So they have multiplied all natural numbers from 1 to 30. They have multiplied all of the natural numbers from 1 to 30. So they wanted to think about this product, right? So they are saying determine the largest value of k so that 3 raised k is a factor to this product. So they want the largest value of k so that you have the largest possible number like this that is a factor to this product. What does it mean, this to be a factor to this product? Which means this value here must be able to divide the answer to all of that. Right? That's what they are saying. They are saying you are given this product here. They are saying find the largest value of k so that 3 raised k is the largest factor. Right? Actually, they want the largest value of k so that 3 raised k is a factor to this product. If k is the largest value, then this will be the highest power of 3. Right? No problem. So what do? They want us to find the largest value of k that we can raise 3 with, so that this is a factor, right, to this product over here. Okay, so here's what you need to know. When you multiply any two numbers, or for example here, all of these numbers up to 30. If you multiply any of those any two numbers there, they will be factor of the answer, because if I'm multiplying 2 and 2, right, and then these 2 and 2 divide the entire thing, will go and cancel themselves, right? If I take 3 and 19, which is in between here, and get the answer for themselves, 3 over 19, I divide the entire thing by 3 over 19. The 3 will cancel itself and the 19 will cancel itself. So if you take any two numbers there and multiply them, that will be the factor of the entire number. So there will be an answer to this, which I think will be like equal to 3 factorial, right? You don't have to mind that, just focus on this. So if you can find your 30 factorial, which is the same as this, 30 factorial, how do you even punch a factorial here? It doesn't seem like I can find it. I don't know how to punch a factorial in this thing. Okay, so your factorial will be the answer to this thing. So if you punch that in your calculator, that you will know how to punch, it will give you an answer to 30 factorial, right? So what I'm saying is, if you take any two numbers here, let's say 30 times 3, the answer to that will be able to divide the entire answer to this, or the answer of 30 factorial, because the 3 and the 30 will go and cancel themselves, or out of those factors that are there. That's what I'm trying to explain. No problem. But now, we want the factors to be in this form, right? Which means it should be a power of 3. No problem. So what I'm going to do is, I'm going to try to write all those numbers there, just to make it simple for everyone. So I'll say 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Right? Okay. I didn't write it very well. Let me just try to clean it. I'll write it. So I'll say 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Right? So times what? Times 11 down here. So I'm continuing with it. Times 12 times 13 times 14 times 15 times 16 times 17 times 18 times 19 times 20 times what? Times 21, right? Times 22 times 23 times 24 times 25 times 26 times 27 times 28 times 29 times 30. So this is all of that, which is the same as that. Fine. Now, we want a factor of that is 3 raised. We want a factor so that it is 3 raised something. And we want it to be the largest possible factor. Because if your k is the largest, you want the largest possible power of 3. Right? No problem. How do you find this? You go into these numbers and identify everything that contain your 3. Right? So for example, here's your 3 here. Here's your 3 here. No 3, no 3. There's a 3. No 3. No 3 here. There is a 3 here. Because your 6 is 3 times 2. So here's another 3. Go and find all those 3s that are in here. And multiply all of them, or count how many there are. So say, let me use another color. If there's no 3, I cancel you. No 3, no 3, no 3, no 3, no 3. There is a 3 here. Because you know 9 is 3 times 3, which is 3 squared. So there is a 3 there. Is it? And then what? At 10, there's no 3. 11, no 3. At 12, there is a 3 at 12. Because 12 is equal to what? 3 times 4. So here's a 3. So we spare 12. 13, 9, 14, 9. It's 15. You know 15? 15, go and check on a calculator the factors of 15. It's 3 times 5. Right? So there is a 3. So 16, no. 17, no. 18, go and check the factors for 18. There is a 3 there, because your 18 is 9 3 squared times 2. So there is a 3. 20, no. No 3. 19, no 3. 21, yes, there is a 3 at 21, because if you go and check the factors for 21, the factors of 21 is 3 times 7, right? Going to be 3 times 7. So there is another 3 there. Fine. 22, no. Go and check the factor of 23, no. 24, yes, because if you remember, the 24 is equal to 3 times 8. So there is a 3. 25, no. 26, no. 27, yes, because 27 is equal to 3 times 3 times 3 is 3 cubed, right? 28, there's no 3 in 28 that I know. 29, no. 30, yes, there is, because you know your 30 is equal to 3 times 1. It's 3 times 10. There is it. So there you are. So if you want the largest possible value of k, right? If you want your value of k, you must multiply all these 3's that are here, right? Multiply all those values of 3 that are there. So what you're going to do, you will say, okay, now our 3 raised k, which is, we're trying to find k, right? So say, okay, now our 3 raised k is equal to this 3, which is 3, which is done with this one, times this one, times 3, times this one, times 3 squared, times this one here, times 3, times this one here, that's another 3, times this one, 3 squared, that's another 3, right? Then this one, times 3, done with it, times this one, times another 3. Okay, I'm not sure where I stopped. Maybe I stopped here. 1, 2, 3, 4, 5. Whoa, what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I stopped there. So there is another one, times 3 cubed. Right? Done that. Times that 3, which is this one here. Then we're done. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. So your 3 raised k will be called the multiple of all these. So this is raise 1, raise 1, raise 1, raise 1, raise 1, raise 1, raise 1. Right? Take the bases are the same, so we'll take one base and add the exponents. So if you add the exponents, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus 3, so that's 14. So it's 3 raised 14. So if these two are equal, right, and the bases are the same, which means your exponents need to be the same as well. So your k should be equal to 14. So in that way, we are done with this question. We're going to move to the next question, which is 1.2. We're done here. Thank you for watching. Cheers.